Hello, my name is Curran O'Driscoll, and along with my co-author Ignacio Fernandez, I would like to welcome you to this brief video abstract on our ION navigation journal paper entitled Mapping Bit to Symbol Unpredictability with Application to Galileo Open Service Navigation Message Authentication. First, some background. Symbol GNSS signals follow open, published interface specifications, which is good for receivers, as anyone with the right know-how can build a functioning GNSS receiver. On the other hand, this is also good for attackers, as they can readily produce fake signals that mimic GNSS signals in every aspect. One solution to this problem is to add unpredictability to the signals. This can be achieved at signal level by encrypting or watermarking the chips, or at the navigation message level through navigation message authentication, which is the focus of this work. Galileo has introduced navigation message authentication to its open service signal, OSNMA. OSNMA consists of 40 bits of information every 2 seconds in the Galileo E1 INAV message, as highlighted in the figure here. OSNMA includes both message authentication codes and signing keys, which can be considered unpredictable. While the OSNMA bits are unpredictable, this is not what is actually broadcast from the satellite. First, a cyclic redundancy check, or CRC, is computed, which depends on the OSNMA bits, and it can be shown that the CRC bits themselves are also unknown a priori. Next, the entire set of data bits, including the CRC, are encoded using a forward error correction and interleaving. In this way, 2 output symbols are generated for each 1 input bit. Now, there exists an attack called the forward estimation attack, which takes advantage of this forward error correction to ensure that the victim receiver decodes the correct bits, even though some of the symbols that have been generated are incorrect. Now, more details of this attack can be found in the paper referenced here. The goal of our work, therefore, is to help in thwarting the forward estimation attack. But how can this be achieved? Well, even if the attacker can cause the victim to decode the correct bits, some of the symbols will still be received in error, as they will have been transmitted in error. If the defender knows which symbols the attacker cannot predict, then they can design an appropriate defense, and that is the motivation of this work. The paper describes an algorithm for determining precisely which bits are unpredictable. Here we see the algorithm in action, shown in the red box. This algorithm maps the unknown a priori symbols in the upper left and splits them into those that are unpredictable in green on the lower right and those that are predictable in yellow on the lower right. The result of this is that no matter what kind of an attack is made, those symbols shown in green on the lower right are never predictable, and we can test these for a high error rate to detect a forward estimation attack. Here we show some sample results for different configurations. On the left, we see the algorithm's division between predictable and unpredictable symbols, and on the right, we see the observed probability of error after applying a forward estimation attack. Note that the green unpredictable symbols on the left correspond to symbols with a near 50% probability of error on the right, while all other symbols have a near 0 probability of error, meaning that the attacker knows them perfectly. So in conclusion, we have developed an algorithm for determining which symbols are predictable given a set of unpredictable bits. The algorithm is quite general, but has been demonstrated in the context of OSNMA. This work can form the basis for a defense against the forward estimation attack. With that, I thank you for your attention, and please do read the full paper in the Navigation Journal at the Institute of Navigation as referenced below.